Welcome. In this lesson we'll learn how to run evaluations on prompt variants, analyze why outputs fail, and turn those findings into a data-driven eval report. This is the core skill that separates guessing from systematically improving an AI feature. Shipping an AI feature without evals is like deploying code with no tests. Evals give you a repeatable, quantitative way to answer the key question: did this change improve the product? As the AI PM, you own both the definition of quality and the discipline of measuring it consistently. Evaluation is a loop. First, define what quality means in measurable terms. Build a dataset of representative inputs with expected outputs or rubrics. Run each variant against the same data, score the results, then analyze failures, document findings, and make a decision. Then you iterate. Pick metrics that fit the task. Use exact or fuzzy match for classification and extraction. Use a 1 to 5 rubric for open-ended answers. LLM-as-judge scales well and is cheap, but you must validate it against human labels and pin the judge model. Add programmatic checks for things like valid JSON. And always show the distribution, not just the average, because a mean of 4.2 can hide a cluster of catastrophic ones. A good eval set needs enough examples to detect real differences, typically 50 to 200 to start. Cover the happy paths, the edge cases, and known failure cases. Tag examples by language, query type, or difficulty so you can slice results later. And hold out a set you never tune against, so you don't overfit your prompts to the test. For fair comparisons, change one thing at a time or run a clean A/B with everything else fixed. Pin the temperature, model version, and seed for reproducibility. Run every variant on the exact same examples. And log metadata like the model, a prompt hash, cost, and latency so results are traceable and reproducible. The score is only the start. Read the actual failures and group them into buckets like hallucination, format violations, overcautious refusals, missing context, and tone mismatches. Count how often each occurs. Then tie each bucket to a hypothesized cause and a candidate fix, whether that's a prompt instruction, a few-shot example, a retrieval change, or a model swap. Interpret carefully. Compare variants on the same examples for sensitivity, and look at per example wins and losses, not just the mean, since small differences may be noise. Segment your results, because a variant that wins overall might lose on, say, the Spanish language slice. And weigh quality against cost and latency, which are real product constraints. Finally, write a decision-ready report. State the goal and question, describe the dataset, list the variants with their prompt diffs, and show a results table with aggregate and per segment scores. Highlight the top failure modes with example outputs and counts. End with an explicit recommendation and next steps so stakeholders can act immediately.